And that brings us finally to chromatic intervals. And chromatic intervals are going to be something we're going to use in every piece that we compose and analyze. So they include the previously discussed diatonic, perfect, and major intervals. And they can have enharmonic equivalent names. Now, all that means is that like F sharp and G flat sound the same, but they have two different names depending on their context. So here are the chromatic intervals within the span of an octave. And you'll notice that it's really interesting. We have the perfect unison, then an augmented unison, and a minor second, which sounds the same. So it's a second, but because the top note's flatted, it sounds minor. Because seconds will become minor, perfect intervals will either become augmented or diminished at first. So those are all the chromatic intervals. And we'll not only work with some exercises in the book, but we'll do a lot of exercises identifying these. So what I'm going to teach you today is how to identify them. So they have some very interesting interval names. So you'll notice, for instance, that the perfect unison, followed by a C against a C sharp, that's an augmented unison. That's what the plus sign means. And it's the minor second, as I mentioned before, C to D flat, sounds identical. Since it sounds identical but spelled differently, we call them enharmonic equivalents. So they're not exactly equal, they're equivalent to each other, but they're enharmonic in that they sound the same. So that's true for C to D sharp. So D sharp and E flat are enharmonic equivalents. E and F flat are enharmonic equivalents. E sharp and F are enharmonic equivalents. So you can have them for almost any two notes that are adjacent. But what's really great about this is that this helps us understand the logic of the way these intervals work, and it's very, very consistent. So we're using large case M for major, lowercase m for minor, the plus sign for augmented, which means we're raising an interval a half step, and then the zero diminished, meaning we're lowering it a half step if that is a perfect interval. So here is something that I found to have great value. You also find this PDF in Canvas. It's the interval alteration chart. So if you look on the screen very carefully up in the right-hand side, it says major key diatonic intervals. I'll put my cursor there. And so this is the place you start to read this chart. Now that should look familiar. You've got all of the major and perfect intervals right here. So what this chart does, it shows us on this horizontal axis all of the unisons, all of the seconds, all of the thirds, and so on. But how you read it is you pick what interval you want to start with. So I'm going to start with perfect unison. Now if I raise it a half step, it becomes augmented unison. Well, what if I raise it another half step? Put a double sharp. Then it becomes doubly augmented unison. Those are not common. We're not even going to use them, but this is just a theoretical concept so that you understand how the logic works. Now on perfect intervals, and if you look at perfect fourth, perfect fifth, perfect octaves, and perfect unison, if you lower them a half step, they become diminished intervals. Now let's look at the major ones. So if let's say a major third, and I raise it a half step, it becomes augmented. So what's so fascinating is all of the diatonic intervals, if you raise them a half step, become augmented. But if you take a major interval and lower it a half step, it becomes a minor interval. You have to lower it 2 half steps to get it to be diminished. And we don't see those very often. So the ones that are right in the middle, you can see where my cursor is kind of circling around them, those are the most common intervals. Now what's the value in this? It's that we can really use this chart to help figure out what interval we're looking at, what chromatic interval specifically. So identifying chromatic intervals is pretty straightforward. I'm going to give you a step-by-step method using the diatonic method. Now, there's some people do it all by half steps. I think that's totally confusing, but this is like bulletproof and really easy to do. And once you catch it, it's just like so simple. So the first thing you do is determine the size of an interval. So if I see two notes, I'm going to count the size by assigning the lowest note as 1. So right here you can see on my chart, between this F and this D, I'm counting the lowest note as 1. Then I count up every space and line. 2, 3, 4, 5, 6. So since that D falls 6 above, it's called a sixth. It's that simple. The important thing is don't start counting on any other line or space. Start counting the bottom note as 1, and then just go up and alternate line, space, space, line, whichever happens to be next. That's the first step. So I don't care what interval you're looking at. If you have two different notes, start counting from the bottom and work your way up to the top. That gives you its size. It's really straightforward. 2, assume the bottom note is the tonic in a major key. Okay, so what we're going to do is we're going to pretend that this F right here, with this F and this B flat, that F is going to be the tonic in a major key. So let me count up. I'm going to go 1, 2, 3, 4. Now this is where you have to know your key signatures. And you've got to have, if you need a cheat sheet on the side, use it. So you ask yourself, is that B flat diatonic to the key of F? So it just happens to be diatonic to the key of F. It's the 4th note in the F major scale. So what kind of 4th is that going to be? It's going to be a perfect 4th. So that's how we figure these things out. So here with the A to the C sharp, I ask myself, I'm pretending I'm in A, the key of A, that's the bottom note. Is that C sharp diatonic to A? You have to know these answers. Now I've looked here at A flat. Is E natural diatonic to A flat? No. So it's going to be an altered interval, a chromatically altered interval, and it's not going to be diatonic. Same thing is true for D. Doesn't have an A flat. It's not diatonic to the key of D. So that is an altered interval. So you really need to know your key signatures. And I have a chart for you for reference. It's also a separate PDF in Canvas for you to use. And it's this one. All the major scales with all of the ordinal numbers. So if I'm looking at F on this chart right here, I look up and I go, there's a B flat. Because remember, that key signature accounts for all the Bs that are going to be played unless there's another alteration. So yeah, that's diatonic to it. But if I had, for instance, the D, let's find D major, it's down here. In D major, and I had a B flat, that's not diatonic. So it's got some altered name. It's a half step lower. It's a minor 6th, not a major 6th. That's how this system works. So you assume the bottom note is a tonic in the major key. You check it against your key signatures. And then here's the third step. Assign qualities to the intervals. So if the upper note is diatonic to the lower note, like we have in the left example in F and B flat, the interval must be perfect or major, and it's labeled either P or M. How do you know which to do? All unisons, fourths, fifths, and octaves are perfect. Everything else is major. So that is a perfect 4th. And then you just label it with a P in front of the 4. Here, you've got A with a C sharp. C sharp happens to be diatonic to the key of A. Therefore, that 3rd is a major 3rd. With A flat, look at this. E natural is a half step higher than the E that occurs diatonically. The E that normally occurs in A flat is E flat. So this is up a half step. It's an augmented 5th. It's totally cool how this works. And then the last one, the D with the A flat that's above it. A flat is not diatonic to the key of D. It's altered. Is it raised or lowered? Flats lower things half step. It's diminished 5th. It's that simple. That's how you have your answer. So then the intervals, we would write them as P4, large M3, or +5 and 0.5. And that gives us our designations for those. This is crucial. And then we have something with these called the consonant and dissonant continuum. Now we talked about in live lecture, consonants and dissonants. Here's one of the first applications of that. The most consonant intervals are on the left side of this continuum. And we say continuum only because this goes off into infinity, really. You could get almost forever, you could figure out tiny differences between things. And the size of intervals could grow out of human hearing and anything reasonable, but it's mathematically possible. So we have the perfect unison, that's the most consonant, followed by the perfect octave, perfect fifth, and then major third, minor third, major sixth, minor sixth, perfect fourth. You'd think that was a perfect interval would be the most consonant. In 18th century counterpoint there, we're going to learn it's considered dissonant. And it's because of its context. I'll demonstrate that in class. And then we have an augmented fourth, sometimes known as a tritone. We have the major second, which is getting really dissonant now, minor seventh, which is pretty dissonant, the major seventh, which is very dissonant, and then the most dissonant chromatic interval in our vocabulary and in our palate is the minor second. So play those. It's kind of fun because you get... with that very dissonant one at the end. We're going to use this as composers and when we analyze music. So we have this further classification. The perfect consonants are perfect unison, perfect octave, and perfect fifth. The imperfect consonances are the major and minor thirds and sixths. Then everything else, we're going to call it dissonance. We're going to call it that way because that was the convention from the 18th century. And you'll see why immediately when we start composing, why every one of those is dissonant. So we use them in composition, and composition is the controlling of melodic and harmonic consonants and dissonance over time. It's the axes we talked about. So we'll refer to the continuum as we compose and analyze music, and we'll use the classification system below. So notice that the perfect fourth is problematic, and like I said, it depends on its context. So all our composing and analysis will use the diatonic and chromatic interval language. And then we'll move from intervals to triads next, melodies and chords and counterpoint. So your next in-class assignment is to bring in a melody, 3 melodies that are 8 bars long. So I'll give you more information about that. And then you will have a PDF you'll want to check out and fill out the answers to that about intervals, chromatic intervals, and bring that to class. So have a great time between now and the next class, and be safe, and we'll see you in class.